So we are dealing with this 13th problem of the first paper, JEE Advanced 2025, and the problem is stating consider an electron in the n equal to 3 orbit of a hydrogen-like atom with atomic number Z. At absolute temperature T, a neutron having thermal energy kBT has the same de Broglie wavelength as that of this electron. If this temperature is given by T equal to Z square H square upon alpha pi square A naught square mn kb, where H is Planck constant, Kb is Boltzmann constant, and mass of neutron is Mn, and A0 is the first Bohr radius of hydrogen atom, then we need to determine the value of alpha. So let's get started with this problem. The problem over here, so let us start with the formula for radius r is equal to r0 n square by z. And since we are writing that consider an electron n equal to 3, so for an electron we can say that mvr is equal to nh upon 2 pi, and over here in this case the Broglie wavelength lambda is equal to h by p. So lambda Broglie wavelength for this electron is h by p, or we can write it as h upon mv. And from here if we put the value of mv, then we can write it as mv, then we are writing it as h upon mv can be written as nh by 2 pi, and then over here we will have r. So over here we get this value as 2 pi r by n. So this is going to serve as the first equation for this problem. So lambda can also be written as lambda Broglie for this electron. If we put this value of r over here as r0 n square by z, then we get 2 pi by n, and r equal to r0 n square by z, and the value which we obtain is 2 pi r0 n by z. So this is the wavelength which we are considering corresponding to the value of electron. Now if we calculate the Broglie wavelength associated with the neutron, so lambda is equal to h upon root over 2m kinetic energy, and kinetic energy associated with this neutron can be written as twice mass of neutron, and kinetic energy associated with a thermal neutron is kBT. So we get something like this. So if this one is considered as the second equation and this one is considered as the third equation, so we can equate equation number 2 and 3. This one is corresponding to electron, this one is corresponding to neutron, and the question is suggesting that both of them are equal. So therefore h upon 2 mass of neutron kBT root under is equal to 2 pi r0 n upon z, and over here if we solve this value for temperature T, so over here we obtain temperature T as z square h square upon 8n square r0 square mn kb. So over here we have slightly replaced the term, so I have replaced r0 with a0 because in classroom we generally use r0, so that's fine. So over here the question is stating n equal to 3. So for n equal to 3, if I put the value n over here 3, then we get z square h square upon 72 times of r0 square mn kb. So over here we can say that the value alpha which we are obtaining is equal to 72. So for this particular problem the value of alpha is turning out to be 72, and this was problem number 13 of first paper JEE Advanced 2025.